Critical path method. Critical path method is used to find the longest duration time of an activity in the project. So the longest duration time is called as the critical path. Now let us see a university problem. Here we have a project consists of activity from A to J with the immediate preceders along with the duration of the time. We have to find or draw the project network, and we have to find the critical path and the corresponding project completion time along with the free float and the total float for the non-critical activities. Now let us draw the project network. We have to see the activities which does not have any immediate preceders. So this is a starting activity. So start with that activities. So 1, they both start the simultaneous time. So A, B, 2 as well as 3. C as an immediate preceder A and B. So C come after B, A as well as B. So we don't have any interlink. So we have to construct a dummy activities. The C1. Then we have to draw C. Similarly, A and B and D comes after A and B. We already have constructed the dummy activity, so we can draw the D. E comes after B, but we have to keep in mind that E also come along with H. So just draw first E. F also come along with G. So F comes after C. So keep it in mind that G also comes. So you have to keep it in mind and draw that F. G and F comes along with H. So we have to construct G such a way that F and G joins. So G. H comes after F and G. So we already consider F and G. So H. But H comes along with E. So we have to consider E. H. I comes after F and G, so I. J also comes after E and H. This is the project network diagram. We have to write the duration of each product along with their names. So A4, B3, C2, D5, E6, F4, G3, H7, I4 and J2. Now we have to calculate the earliest start time as well as latest completion time. So start with each activity we have to consider. This is called as the earliest start time. This is the latest completion time. So for each activity we have to calculate the earliest start time as well as earliest completion time. The formula for calculating the earliest start time, that is ESJ is equal to maximum of ESI plus DIJ. Similarly, latest completion time is equal to minimum of latest completion time minus DIJ. So since we have to consider this as a activity, this is DIJ, this is ESI, this is ESJ, LCI and LCJ. So we have to calculate the latest start time and earliest start time and latest completion time using this formula. First, for each activity the starting will be 0, initial value will be 0. Next we have to add 0 plus 4. So no other incoming activities is there, so we can consider as 4. Similarly, this is a forward, calculating latest start time is a forward path. So B 0 plus 3, again 3. Similarly, 4 plus 2 it is 6, 4 plus 5 it is 9, but then for 7 it has 2 incoming arrow. but we have to take the maximum value. 6 plus 4 it is 10, 9 plus 3 it is 12. So the maximum value is 12. We can consider 12 as the maximum value. Similarly, 6 plus 3 it is 9, and 12 plus 7 it is 19. So we have to take the maximum value, that is 19. Similarly, 12 plus 4 or 19 plus 2. 19 plus 2 as the highest value, that is 21. We can consider 21. Now we have calculated the earliest start time. We have to proceed a backward path for calculating the latest completion time. Start with 21. So 21, the incoming arrow, the reverse path calculating for 6, it is 21 minus 2. So 21 minus 2 result in 19. Similarly, for 7, it has two outgoing arrows. So one is I, one is 7. So 19 minus 7 result in 12, whereas 21 minus 4 result in 16. 16, 12. We have to take the minimum value. So 12 is the minimum value. Take 12. Similarly, for 12 minus 3, so we have only one outgoing arrow. So we have to consider 12. 12 minus 3, it is again 9. Similarly, 12 minus 4, it will result in 9. Then we have to consider the 19 minus 6, it is 13. Then 7, 12 minus 4, it is result in 8. This value is again 8, 6 minus 2 as well as 9 minus 5. 6 minus 2 it is 4, again 9 minus 5 4, so we can take any 4. So we have calculated the latest start time as well as the earliest earliest start time and the latest completion time for the network flow. Now we have to calculate the critical path. Critical path is nothing but the activity which has the same earliest start time as well as latest completion time. So starting with 1, this has 0 0 starting. Then activity 2, it also have 4 same latest start time and earliest start time and latest completion time. And again 5, 7, 19 and 21 have the critical path which have the same value for both. So mark that path. In this network diagram, we have two critical paths. One, this path. The second one is the black one. The second path is but we have to write the two critical paths. The two critical paths is, the first one is A to D, D to G, G to H, H to J. The second critical path is A to D, D to G and G to I. Calculate the path for each. From A it is 4 plus 5 plus 3 plus 7 plus 2. It is 21. Whereas for this 4 plus 5 plus 3 plus 4, it is 16. Critical path is nothing but the longest duration. So 21 is greater than 16. So 21 is the longest duration, right? So this comes under the critical path. And this is the project completion time. We have calculated the critical project network, critical path as well as the project completion time. Now we have to calculate the total float as well as the free float for the non-critical activities. We already know that the critical activities are A, D, G, H as well as J. So for all these critical activities, we have the free float as well as the total float as 0. Otherwise, if you want, we can also calculate the formula. Now we have to calculate the free float and the total float for the non-critical activity. We already seen that critical activities are A, D, G, H and J. The formula for calculating free float and the total float is, for free float it is J is equal to EST, means earliest start time minus earliest start time of I minus Dij. Whereas for total float Ij, it is latest completion time of J minus earliest start time I minus Dij. Similarly, we have to consider this activity. It is ESI, LCI, ESJ, LCJ. For free float, this minus this Dij. For total float, this minus this total float. This is for free float. Now let us calculate for the activities with non-critical activities B, C, D, E, I. So from the network diagram, for calculating B it is from 1 to 3B. It has an activity of 3, 0, 0, 13 and 3. So the free float it is 3 minus 0 minus 3. It will result in 0. Whereas the total float is 13 minus 0 minus 3, which will result in 10. So we are going to write it as free float it is 0, total float is 10. For the non-critical activity, for the critical activities, the free float as well as the total float will always be 0. If we calculate also, will result in 0. The next one is C. This from the C, this is the activity. So 2 to 4, C does 2, 4, 8 and 6. Free float it is 6 minus 4 minus 2, it is 0. For total float it is 8 minus 4 minus 2, it is 2. So free float it is 0, but total float it is 2. Similarly, we have to calculate for each activities, that is non-critical activity, E, F and I. For E it is 10. For F it is 2, and for I it is 5 and 5. Thus we have already calculated for the project diagram, the critical path, the project completion time, as well as the free float and the total float for the non-critical activity. Thank you.